Welcome to our module on Advanced JavaScript and Frameworks, where we'll explore powerful concepts for modern web development. Our focus will be on mastering asynchronous operations, a crucial skill for building responsive and efficient web applications today. Let's begin by defining a fundamental concept. What exactly is asynchronous programming in JavaScript? It's key to enabling highly responsive web applications, ensuring your user interface remains smooth and interactive. At its core, asynchronous programming allows JavaScript to perform long-running tasks without blocking other operations. This means tasks can run in the background, which significantly enhances the overall performance of your application. It's a non-blocking approach. Your application remains responsive while waiting for operations to complete. These background tasks improve the user experience by preventing the UI from freezing during heavy computations. Asynchronous programming is also event-driven, relying on mechanisms to manage task completion. It uses callbacks, promises, or the more modern async/await syntax to effectively handle when tasks are finished. Now, let's visualize the typical flow of an AJAX request, which is fundamental to asynchronous communication. It all starts when the browser initiates a request, often triggered by user interaction or an application event. Next, the server processes this request, retrieves or manipulates data, and prepares a response to send back. Finally, the browser receives the server's response and updates the web page dynamically without a full reload. Let's delve into the Fetch API, examining its syntax and practical usage for making network requests. The Fetch API allows us to make modern HTTP requests, leveraging JavaScript promises for cleaner asynchronous code. Here, we'll look at the basic syntax of the Fetch API to understand how it initiates network operations. The Fetch API initiates a network request, returning a promise that resolves to the response. The then method handles successful responses while catch handles errors. This code snippet shows how to make a fetch request, handle the response, check for HTTP errors, parse JSON data, and catch any potential errors. Now, let's see a practical example of a simple GET request using the Fetch API to retrieve data. This example demonstrates a basic GET request to retrieve data from a specified URL. The first then converts the response to JSON, and the second then processes the data. This code illustrates how to fetch data from a public API, convert the response to JSON, and then log the resulting data to the console. Today, we'll explore the fundamental differences between AJAX and the modern Fetch API for web requests. We'll focus on their key distinctions when making asynchronous web requests, which are crucial for dynamic applications. Let's compare them across various aspects, understanding how each handles different parts of a web request. First, consider their syntax, which dictates how you write the code to initiate and manage these requests. Next, we'll look at their browser support, an important factor for ensuring your application works across different user environments. Then, we'll examine how they handle data, specifically how they process responses received from the server. Finally, we'll compare their error handling mechanisms, which are vital for building robust and reliable applications. Now, let's dive into AJAX, which stands for Asynchronous JavaScript and XML, and its characteristics. AJAX typically involves more verbose code and often requires multiple callbacks to manage different stages of a request. A significant advantage of AJAX is its widespread browser support, working in virtually all major browsers. With AJAX, you usually need to manually parse the response data, for example, using JSON.parse for JSON. Error handling in AJAX is primarily managed through the owner event, which can be somewhat limited. Now, let's turn our attention to the Fetch API, a newer and more powerful standard for network requests. The Fetch API offers a cleaner, more modern syntax, utilizing JavaScript promises for asynchronous operations. However, Fetch API support is generally limited to modern browsers, so consider compatibility for older systems. A great feature of Fetch is its automatic handling of JSON data using response JSON for easier parsing. Fetch provides enhanced error handling with the catch method, allowing for more robust error management in your code. Let's now explore the significant advantages that JavaScript frameworks bring to modern web development. These frameworks are designed to streamline the entire process of building modern and complex web applications. One major advantage is their component-based architecture, which encourages modular and reusable code. This means you can create reusable UI elements, leading to much faster and more efficient development cycles. Frameworks often lead to improved performance in web applications, especially with dynamic content. They achieve this through efficient updates to the document object model, frequently utilizing a virtual DOM for speed. Effective state management is another key benefit, helping organize data within your application. This greatly simplifies how data is handled and shared across the various, often complex, parts of your application. JavaScript frameworks significantly boost developer productivity by offering a structured environment. They come with built-in tools, extensive libraries, and strong community support, accelerating development tasks. Finally, frameworks greatly enhance the maintainability of your web applications over time. They promote modular code, making it much easier to debug issues and extend functionality as your project grows. Now, let's take a quick look at 3 of the most popular JavaScript technologies: React, Vue, and Angular. We'll examine their core characteristics and discuss the ideal use cases for each, helping you choose wisely. We will compare these technologies across several important aspects to highlight their differences. First, let's consider their type, whether they are a library or a full-fledged framework. Next, we'll look at the primary language used for development within each of these ecosystems. Then, we'll consider the learning curve, which indicates how easy or challenging it is to get started. After that, we'll discuss their approach to data binding, an important concept for managing application state. Finally, we'll identify the ideal use cases for each, guiding you on where they shine best. Let's start with React, developed by Facebook, widely known for building user interfaces. React is primarily a library focused specifically on building user interfaces, not a full framework. It uses JavaScript, often combined with JSX, a syntax extension for writing UI components. React has a moderate learning curve, becoming more intuitive once you understand its core concepts. React employs one-way data binding, meaning data flows in a single direction for better predictability. React is ideal for building dynamic, lightweight applications, especially single-page applications with complex UIs. Moving on to Vue.js, a progressive framework known for its approachability and flexibility. Vue.js is considered a progressive framework, meaning you can adopt it incrementally into your projects. It supports both JavaScript and TypeScript, offering flexibility depending on your project's needs. Vue.js is often praised for its easy learning curve, making it accessible for new developers. Vue.js typically uses two-way data binding, simplifying synchronization between your model and Vue. It's an excellent choice for small to medium-sized projects, offering a balance of features and simplicity. Lastly, let's discuss Angular, a comprehensive framework maintained by Google for enterprise-level applications. Angular is a full-fledged framework, providing a complete solution for building complex client-side applications. Angular primarily uses TypeScript, which adds static typing to JavaScript for improved code quality. It has a steeper learning curve compared to React and Vue, requiring more initial investment to master. Angular strongly supports two-way data binding, which automatically synchronizes data between components and the UI. Angular is particularly well-suited for building large, enterprise-level applications that require robust structure. Let's delve into understanding application state, which is essentially all the data your application manages. We'll explore the different categories of data that exist within front-end applications and how they are used. Local state refers to data managed exclusively within a single component, such as values in form inputs. Global state is data shared across multiple components, like a user's authentication status throughout your application. Server state involves data fetched from a server, which then needs to be synchronized with your application's UI, like API responses. UI state is data that controls the application's appearance and interaction. For example, whether a modal is visible. Let's now summarize our key learnings from this section on advanced JavaScript and frameworks. We'll focus on the most important takeaways you should remember regarding advanced JavaScript and its frameworks. Remember, asynchronous programming is crucial for creating responsive web applications, often using a JAX or the Fetch API. The Fetch API provides a modern, promise-based way to handle HTTP requests, leading to much cleaner code. JavaScript frameworks such as React, Vue, and Angular offer structured methods for building sophisticated user interfaces efficiently. These frameworks strongly promote a component-based architecture, significantly improving both code reusability and maintainability. Effective state management is absolutely vital for ensuring data consistency across all your application's various components. Finally, single-page applications deliver seamless user experiences through dynamic content updates without full-page reloads.